Thank you for joining. Today I'm going to be talking about going above the clouds with Snowflake's database replication. What we mean by that is, as you may already know, we are a cloud data warehouse. So, we were cloud native. We often say we were born in the cloud. However, that's more accurately stated as we were actually born on AWS. And so from the very beginning, the Snowflake platform was built on top of AWS services, so S3 for our storage and EC2 for our compute. Then in July of last year, we ported over into Azure. And at that point, we were already cross-cloud, right, which was a big jump for us and a really great milestone. What's coming next will be on Google Cloud. And so you can kind of see from this perspective, Snowflake's in a very unique position, because not only do we enable you to spin up your Snowflake account in any one of these major cloud provider platforms, we also now allow for cross-cloud and cross-region replication, and we've simplified that whole process for you. So today's session, I'm going to be talking about kind of replication and how it applies to some key themes that we hear from customers. So to put this into perspective, earlier this year at our customer conference, we sort of introduced these product pillars that our team has. Obviously, today we're going to be talking and focusing really on global Snowflake, but this is how it fits into our overall strategy. Global Snowflake, obviously referring to being able to leverage Snowflake regardless of what region and what provider you're based on. Really at the heart of this all is the risk of failures. So across cloud and a multi-cloud strategy, at the heart of it, being a global landscape, we know that most businesses will need systems to be very reliable and available 24/7. However, the reality is that outages occur all the time for a host of different reasons. It could be network issues, natural disasters, or even human error. And so to address these types of challenges, Snowflake developed this cross-cloud, cross-region database replication with failover and failback to allow for very quick recovery of data, no matter where your business operates and what cloud you're running on. And so just a couple of examples of how this might look. We already have customers doing this quite actively in the US as well as locally. So whether they're going from west to east or from AWS to Azure, the mechanism underlying is the exact same. Just to point out here, we announced this database replication across all editions from standard all the way up to business critical. However, the database failover and failback is only available in this business critical edition of Snowflake. So just to keep that in mind. I'll be demoing both things today. And at the moment, VPS, which is our virtual private Snowflake standalone instance, quite rare to see, to be honest. Most of our security conscious customers are on business critical, but with VPS, it's yet to come in terms of the replication. Okay, so what are the key use cases we see for database replication? The first and most common is to do with business continuity and disaster recovery, is what we just spoke about. So when you think about business continuity, there are kind of three main steps. The first is you identify what those critical applications are. You assess what the impact of downtime might be to those applications, and then you set a recovery point and a recovery time objective. Right? Now, Snowflake already covers some of the concern when it comes to reliability. And really the reason for that, if you think about the components of our architecture, again, we are on Azure and AWS right at the moment, we leverage the resiliency of those platforms. And we will automatically make sure that you are across the availability zones in the case of AWS here. So if you think about how Snowflake addresses the main areas of risk of business continuity. The first around customer error is really to do with the features that are built into the product. So time travel, which allows for essentially rolling back to a point in time or even a specific query. Fail-safe, which keeps your data for up to, I think it's 14 days. And but with fail-safe, it's recoverable by Snowflake for you in case of a disaster happening. For a single instance failure, so this is talking more about the actual compute nodes. So if a cluster fails, we already have redundancy built in. So again, because we're leveraging those cloud services, we have that redundancy built into this virtual machine layer of the architecture. And so if a query was to fail on a virtual machine because something happened to that machine, it will automatically get retried. Zone failure. So if a single zone within a region were to go down, we have redundancy and resiliency against that already as well. So this is because we're using those availability zones and availability sets on each cloud platform. Now, the last two is where the line was sort of drawn in the past. So the first, region failure. So a loss of service availability if a whole region were to go down. In the past, this was really the customer's responsibility. You could have two separate Snowflake accounts and just manage the resources across them manually. If multi-regions failed, same sort of thing, right? If the impact obviously might be bigger, but essentially it's the customer's responsibility at this point to put in place some sort of mitigation. Now, the current state of the affairs, so the first three are the same. The last two here, this is really where database replication and failover come into play. So with database replication and database failover, we now can mitigate against region failures and even multi-region failures, or even full cloud failures, right, by implementing this sort of strategy. So how it really works under the covers is we essentially have a primary database. Actually, step back from that. Before you can even create a primary database, you need to put a request in to essentially link your accounts. Now, this is going to be self-service going forward, but for the time being, this needs to be a request. At that point, accounts are going to be linked, and they'll be part of a global organization object, essentially. Once you then set a primary database, you can allow for replication to other accounts. So again, could be another region in the same cloud, or it could be another cloud completely. You then run a refresh on that secondary in order to replicate data from the primary to the secondary. And actually, I should have changed this because it just changed. You actually don't even need a stored procedure anymore. You can run that through a task directly. Just to note, there are three main aspects to the cost associated. The first is data transfer costs. This is just the same as you would pay the cloud provider directly. So depending on which region, which cloud, and so on, there's some egress charges involved. Storage costs, so because you're replicating data in this case, you're going to need to pay for the storage in two or more places. And then finally, the compute that's involved with the replication itself. So because it's serverless, you don't need to spin up your own compute resource to do the replication itself. It runs as a background service, and then similar to something like a Snowpipe, we will charge back in terms of the number of credits consumed. Database failover. So if one account or region goes down, you can promote the secondary to the primary. And again, across regions, across cloud providers. The biggest thing here that I want to point out is that at the moment, this is just for databases. So not an entire deployment, right? So users, roles, and so on. That's coming, and we'll talk a little bit about roadmap later on, but at the moment, this is just for databases primarily. Okay, so three main steps. So the first is, of course, preparing for an outage, so having the accounts in place to begin with, linking them, and setting up the replication across. Now, the second is to monitor the availability of the service. We have a status page you can subscribe to, which I'll point you to later down the track. And then if an outage does occur, you can then fail over to your secondary and point all your client applications to that secondary. What this means is, again, cross-region, so you could have data loading into AWS Sydney normally. You have a replication set up to AWS Singapore. Say Sydney goes down, you can then point your loads over to AWS Singapore, and then when AWS Sydney is back up, replicate back over to Sydney. And sort of the same thing for cross-cloud, right? So AWS Sydney to Azure Sydney, for example, and that's what we're going to be demoing. So thinking about what I'm going to be showing here, this is the setup that I have. So I have my main primary account with the orange here in AWS Sydney. I then have two other accounts, Azure in Sydney and AWS in the US. Those are both going to, they could potentially be secondaries. We're really going to just focus though on Azure. So we can set up replication from AWS Sydney to Azure Sydney, as well as AWS Sydney to AWS in the US. Okay, so let's jump right in then. Okay, so there are a couple moving parts, so hopefully I won't be too confusing when I switch over. But I'm going to be starting here. The best way to actually keep track is I've tried to name the account something that makes sense to the users at the top right. So right now we are in AWS Sydney. Okay. And so the first thing I'm going to do from AWS Sydney account is using my account admin, I am going to show all of the global accounts that I have. And this is where I can check which accounts are linked together. So like I said just now in that map, I have an AWS US, AWS in Sydney, and then Azure in Australia, or in Sydney. I can check where I am now. So yeah, I'm in AWS AP Southeast 2, which is in Sydney. And then here's where I enable replication to specific accounts. So I'm going to use the CityBike replica database, and I'm going to enable replication to those other two accounts that are linked. And then I'm also going to enable failover. Remember, failover is only for our business critical edition, which in this case I'm running. Okay, so those two ran successfully. Now I'm actually going to add some data into the CityBike replica database. So if we take a look on the left-hand side, under public, there's a few tables here with some information, but my main table with trips is empty. So 0 rows there. So what I'm going to do is quickly just load in some data. So I'm going to use data that's been staged here. I'm going to copy in just 1 year's worth, so the data from 2019 to start. This just gives us a starting point. And once this is completed, and I can obviously track all of that on the history, I can then see that we have about 11.2 million rows of data loaded in. Okay, so now that I've set that up on my AWS Sydney side, I'm going to switch over now, and I'm in Azure Sydney. If you really want to check, you can look at the URL here, so AZ Australia East Azure. And from here, what I'm going to do is first set my context. I'm also going to show replication databases from this side. So you can see here that we have where the primary is coming from. So it's from AWS AP Southeast 2, which is AWS Sydney. It was just created, and it is the primary here. So here, and then where it says replication allowed to, this is where I can see which accounts I've enabled replication, those 3 accounts. So from here, I'm going to create a replica from the replica that was just in AWS Sydney. So we now have something called a global database. And essentially what this is, if I open it up here, is nothing has been loaded yet because we haven't actually refreshed the database itself. but this is going to be our secondary, right? So it's read-only. It's still accessible, but you can't make changes to it until it's promoted to a primary. I'm then going to do some permissions. So I'm just going to grant some permissions to my other role here, my data DBA role. And then once that's all done, I'm going to run the alter database refresh command. So this is going to take a little bit of time. What it's doing is it's scouring from one account over here, so my AWS Sydney, and comparing it to my Azure Sydney account. Once it's done that and looked at all the metadata and really established what needs to be replicated, it then will transfer the data across for us. So again, we're going from AWS Sydney as our source and replicating over to Azure Sydney. Now, instead of sitting here and watching this, let me just switch back quickly to our slides and walk you guys through exactly what we just did, right? So the first thing we did was from our AWS Sydney primary account, we checked to see what other accounts were linked. This is at the moment, again, a request that you have to make. So you submit a support ticket and support will be able to link your accounts. You just need to verify that they are in fact yours. Once that's done, you'll see under the Show Global Accounts all of those linked accounts. You then have to enable replication, and if you have it, failover to the accounts that you need. You can then verify that shows up when you run another show replication databases. You then switch over to your secondary account. And if you run the same command, show replication databases, you should see that replication CityBike replica coming from AWS and is available to you. You can then create a database from that, which is essentially known as that global database. It's at the moment the secondary, again, read-only. And then if you run the show replication databases again, you should be able to see now two lines in this. One that shows you the primary in AWS, and the second that shows you the secondary in Azure. The last step that we did was to run the refresh itself, and that's what kicks off the whole replication. Now, instead of, and again, this has just changed, so it's even easier than this. In the past, just to give you context, in the past, you would have to run DDL in a stored proc in a task. It's since changed. So this create task command, and I'll show it to you in the UI, is actually much simpler now. But essentially what this is saying is we can create a procedure. What this procedure is doing is it's just calling, or it's just running an alter database refresh. And then the task, which is a task that can be scheduled on some kind of cadence, will then call that procedure. In this example, it's a 10-minute window. Again, that depends on the business need and how long as well it'll take to replicate. So one thing to note here is if you try to run a refresh when the last refresh hasn't finished, it will fail. Right? So something to take note of. Just looking at what that might look like in the UI. So again, it is more simple than writing a stored proc. So I was able to remove all of that. But what we can do here is to create a task. The first thing is you create a task warehouse to tie the task to. So here we're going to create a task warehouse. And then we're going to create the actual task. And here's where I was saying it's actually even simpler, where I can create a task. It's going to run every 30 minutes, and it's going to run this SQL command, right, which is the same one we just ran manually, alter database, CityBike, replica, refresh. We then start the task, and then we can monitor when the next run is going to be. Just to give us some time, because I don't want it just to be running in the background, I'll make that 60 minutes. I'll resume the task. I can show you that task is now created and enabled, and then we can query the information schema. There's a task history view that we can essentially look at to see when is the next run going to happen. So here, when this pops up, we should see it'll run in about, in 60 minutes. And you can see the full history of the ones from before. Cool. Okay, so that ran, again, it took about 3 minutes, 11.2 million rows. Note that there's not necessarily a linear correlation there because there's some overhead, so sometimes the number of objects can have an impact as well. But nonetheless, from now our Azure Sydney account, we should be able to explore that data that was just replicated. So if I were to refresh the pane, I'll now see those same programs, stations, trips, and I can show the replication history as well. So here I can see that the metadata was uploaded, the data itself was uploaded, the inventory was refreshed, and so on. I can also look at the refresh history. So that was the refresh progress, and I can see that it was completed. And this gives us the latest run and when did it finish. So as we can see all the tables, and there's a view as well, and that was all replicated from AWS Sydney. Okay, so we just showed replicating about 11 million rows of data across from AWS to Azure. And we also showed how we can schedule that with a task. So looking at this again from the main points, I guess that you want to look at here. So there's obviously the cross-cloud, cross-region, but there's also the fact that there's no performance impact as you replicate on the primary itself. So because it's run as a background service, it also doesn't affect any processes that are running on that primary source. It's not like it locks it or anything like that. The refreshes happen incrementally after that big first one. It's instantly recoverable, so we'll see in a second how it works when we want to fail over. It's just a metadata operation at that point. It's secure, so that question comes up quite a bit. All the data, as always, is encrypted at rest and in transit. Even if you have try-secret enabled, it will also, we don't require you to use the same key, first of all, across the two accounts, and we'll ensure that all the data is always protected. And then it's cost-effective, right? So there are a few pieces of cost involved when it comes to data transfer and compute, but obviously data transfer applies regardless, and we've seen that the compute is very affordable for what you're getting out of this replication. And finally, you can also control at the database level which ones you want to replicate. Okay, so let's switch over and talk a little bit about failover and failback. Again, these two features are for our business critical edition. So in the case that AWS were now to go down, we would fail over to Azure. And the way that will look is from the Azure account, we are going to run an alter database and set it to the primary. And that's it. So if we switch over, this is pretty simple. From my Azure Sydney account, I'm going to alter the database, set it to the primary, and just like that, we are now running as the primary database. We can test that by trying to load data into the replica. So here we're going to just load the 2018 rows. So now we can see that we have both 2018 and 2019. Sorry, it's a bit hard to see there. And if I count the number of rows, we're now up to 28 million. Cool. So, wrong one. So when AWS then recovers, this is simply a matter of replicating back to AWS and doing a failback. Okay. And then switching primaries over again to that AWS instance. So in this case, it's the same except reversed. So I don't necessarily need to show you this. I think probably that was clear from the last round, but think about it is just reversing what we just did, right? So from AWS, we now run the refresh and make sure that we get any changes that might have happened during that outage. And then we set it to the primary. Once that's over, we want to make sure that it's successful and we can run that same show replication databases and run it that way. We might actually be able to run this in the background. So if I switch over to AWS, I'm just going to run the refresh again. The other thing I wanted to point out is notice how the warehouse isn't active, right? Again, because that's a background process. I don't need to resume any compute on my own. I can just rely on Snowflake managed compute services. While that's running, what I'm going to jump into next is how we might enable sharing in the same capacity. So just a little note here, sorry, on just the status page. I mentioned it before, status.snowflake.com. You can subscribe to updates. You can apply to the emails or texts, or there's an RSS feed and so on. So you can subscribe to specific regions and specific clouds as well. Okay, so I'm going to switch over now to the second use case for replication, which is data sharing across regions and clouds. And I think this is really quite interesting because it's quite often we hear that people have data sharing needs, and not always are you aligned with either the cloud you're on or the region, right? And so we want to ensure that you're able to do that sharing seamlessly and not be held back by that. So with replication, we enable secure data sharing like we normally do, but this time it's cross-region and cross-cloud. So if you think about the current typical process of sharing data from provider to consumer, it's usually very manual. It's time-consuming. It's static, right? So it's a process that needs to run over and over again, or it involves maintaining some kind of API. So typically, we speak to customers that want to do data sharing, but have held back a little bit because of the pain involved. And so with Snowflake replication and data sharing, we envision this world where, if you're living if you have an instance in Australia, you'd be able to instantly share that information with someone in the US. Again, seamlessly, securely, and only do it really one time. Set it up one time, make sure that it's refreshing, and just monitor it. Now, the way that this works is, so say you have an AWS provider account, and you can then share from that account with a few consumer A and consumer B. You would replicate the database to share with an Azure proxy account. So you would open up a Snowflake Azure account for this use case, or have one for replication failback purposes anyways. And from that proxy account, you can share with customers on Azure. So a couple points to note: this is not a federated query model. You only need to copy once per region or per cloud. You don't need to have copies per customer or consumer. You can essentially share with as many consumers as you want from that proxy account. And cross-cloud is the main thing. So no one else can really do this in the way that we are. And again, that speaks to our position that I reckon is quite unique. Just a couple of quick examples of what that would look like. Simplest version, again, of this is replicate a crop and then share a view from there. Slightly more complex might be if you need to then have security tables to implement row-level security, or you might have source and then you need to mask certain items and pull that into a shareable version. You can also do that. Okay, so data sharing. Again, I'm going to do this from Azure. So this was where we were switching over to the primary. I actually think this finished. Yep, so this time it finished in 1:57. Obviously not much had changed, just those rows that we added. And so once that refresh completed, we can switch over back to AWS as the primary. So if we were to show the databases again, let's just make sure that that worked. So yep, we have AWS, and that's set to our primary again. So we've just failed back to AWS. All right, so switching to Azure. Here we are going to, first of all, create a share called the CityBike replica. And we're going to grant usage on the database as well as the schema and this secure view called secure trips view. So that secure view contains some logic. It's using a security table to ensure only the rows that the consumer can see are visible. So we'll run these commands here, done that. And then the last step here is we'll just add our reader accounts. So these are our consumer accounts to the share. I'm not going to go into too much detail, but I will just point out from the account page, this is where you'll see and be able to create reader accounts. In our case, we have, this is our Jersey City Housing Authority, and this is the New York City Housing Authority. We're going to share some specific data with those two parties. Okay. All right, so we just added those accounts to the share. One cool thing we can do, a little trick here, is we can alter the simulated data sharing consumer variable to be able to check that this is working as expected. So for example, if we were to switch over to the New York City account, we could run a query against the view, and we should only see the New York City Housing Authority's membership names in this case, right? So it's working as expected. I'm going to unset that. And then what I'm going to do is go into this account. So this HQ76881, that's an account name, which I'm connected to here. So HQ76881, it's in Azure Sydney, so it's in the same region, same cloud. And from this account, I can come in and consume the share. So first of all, I'm going to show what shares are available. If I sort by when they were created, we'll see that just a moment ago at 2:34, the CityBike replica share was created and shared with us. So what we can do is we can create a local inbound sort of database based on that share, and we'll grant some privileges to our sysadmin. So now that we have granted that access, you'll notice the little icon is slightly different. So it has a little arrow pointing into it, and that just means it's coming from a share. It doesn't live in my account, and so essentially I'm not paying storage for it. Now from this account, what I can do is, first I can do a count to see how much data I've been given. It's a subset of that full 28 million rows, right? It's 700 or it's 670. And then just to double check again, when I run a select, I can only see the program names associated with the New York City Housing Authority. So that was secure data sharing and how replication really enhances the way that we already share data by allowing you to do it across regions and across clouds seamlessly. The last use case that we see replication for quite often is really more for portability and migrations from one cloud to another. So maybe you're moving from one region to another or from a cloud provider to a new one. So you might have started on AWS and since then have decided to move over to Azure or to Google Cloud. well, you can use Replication to assist in that migration. Currently, this can be quite, again, time-intensive, labor-intensive, and so on. But with Replication, it becomes much, much easier. A couple of technical considerations with Replication that I want to point out. The first is that it's not storage level replication, so it's not like S3 replication. It ensures transactional consistency. We only replicate what's been committed. The second is that it's serverless. It doesn't require your own virtual warehouse to be spun up and managed. It's run, again, as a service with Snowflake managed resources. And you saw that in the demo. The next is it's asynchronous. So the secondary database might have slightly older data depending on how often you're running the refresh. Right? So you might have to replay some of your processes after the failover to recover any lost data in between. The fourth point, again, I'm going to stress this because it's very important. It's not full account replication. So it excludes users, roles, privileges, warehouses, all of the other objects surrounding the database. It also excludes some objects, so stages, types, external tables, streams, and tasks. And then any database that's created from a share can't be replicated again. So that's just a limitation that we have in general for shared information. You either have to, copy it in, do a C task in, and then replicate it, or move it in some other way. Failover, as you saw, is controlled by you, so it's not automatic. You essentially have to run a command. And currently, you still need to switch over your client tools to your to the other account when you do a failover. What's coming to enhance this addresses some of those current limitations. So the first is full account replication, and this is the one we get asked about probably the most often. The ability, obviously, to replicate everything in your account, including all the users, roles, privileges, and so on. So that is being worked on currently as sort of the next iteration. The second is transparent connection failover. So this means no disruption to any other tools that are pointing at your Snowflake instance, whether they're BI tools, ETL tools, and so on, will essentially be able to fail over, and all of those tools won't know that anything had changed. So for me, this one is probably, first one is pretty important too, but being able to ensure that there isn't any effect or impact on those end users is obviously always important. And then the third is around the failover of your ETL processes. So being able to replicate all of the objects related to loading and transforming your data, so stages and pipes and streams and tasks. But essentially what this will prevent is any duplicate loads, and we'll be able to replicate the copy history, ingest history going into your primary account this way. Okay, well, that's all I had. So if anyone has any questions, feel free to enter them into the Q&A. I will answer them as they come in. Otherwise, thanks again for your time. Hopefully that was informative, and hope to see you again next time.